I'd like now to introduce the first speaker who can already put his presentation. It's Sebastian Ha at Merck, to my very best knowledge, and it stands in my book. 1999, they made the first production plant with microreactors at a time where many people thought this is impossible. So this is a big historical credit of Merck company. And they approach it from the engineering side. We will hear talks today from the chemistry side as well, but Merck does it from the engineering side with very innovative ideas. And Sebastian Ha works in process development, principal project lead, electronics. And it's from the German Merck. It's not the American Merck, just as it's not mixed. We will hear also from MSD, from the American Merck talk, but this is from German Merck. Sebastian gained his diploma in chemistry at the University of Marburg, it's just 16 kilometers where I come from, and finished his PhDs in applied physical chemistry in 2006. Then he joined Merck as a lab manager for quality control, and in 2009 he took over the group lead for process intensification, and that's all what microreactors are about. He led different worldwide projects for process intensification and new technology implementation, and we'd like to hear something of that today. Since 2018, he's a portfolio innovation manager in the engineering department and the principal project lead for smart manufacturing initiatives in Merck. So, Sebastian, we look very much forward to your talk, Modularization and Standardization as enabler for speed and efficiency. Go ahead and have a look on the time because we want to allow a few questions later. Thank you.
So now I will share the screen and hopefully everything is working. Give me a second. Everything is coming up?
Wonderful. Go ahead. We all see it.
Perfect. Yeah, thanks, Volker, for inviting me. And I think it's really this journey which we really followed long years, and also Professor Löwe was a very important person for us in Merck, and we had a lot of nice projects with him. I think it's, and you explained it, we're coming from the engineering part, and you will see it later on the slides. There will not be really a detailed example for a chemistry, what we are doing, but I think I would like to give you an idea of what is, let's say, our driving force to use flow chemistry as one major technology in our organization, and especially why are we driving this forward. So with this, modularization and standardization as enabler for speed and efficiency. I tried to give a short overview a little bit of Merck, because it's important that you understand what kind of drivers do we have. Then give a short idea of the topic of a smart factory. This enabled connectivity is very important for us, and you will see later on how we are using it and how we're realizing it. Data is the new oil, and I think this is for each of us very important for the future. And with this, I will then finish it a little bit with this idea of a future network. Where are we working and how are we using it? So with this Merck introduction, and I will keep it really short, but important to mention is really we have electronics. Electronics is most, let's say, focused on materials for semiconductors and for display materials. We have healthcare with a focus on new product or new API synthesis. There is biomanufacturing and small molecules inside. And we have for sure life science with a really broad, let's say, organization. Everyone knows Sigma Aldrich, which is part of our life science organization. So with this, it's clear we have a very broad and diverse portfolio of materials here, which we are producing. And with this, we have a lot of different kind of challenges we have to face. But I would like to focus a little bit on electronics, and everyone it's clear, only just looking into a smartphone, there are different kind of chips inside. We have different kind of processors inside, and a lot of these systems we deliver the companies for performing the production of these kind of chips. So with this, and keeping in mind what is showing on the Moore's law, and all of us know this very well, we do see more and more different kind of chip technology coming up. The complexity is more and more, let's say, growing, and with this growing complexity, electronics is driven by our customers that we have to supply different kind of materials in a very, very short life cycle time, a very high quality of these materials. And we do see it also for the life science and for the healthcare parts. So if we do have this topic of pharmaceuticals, for personalized medicine, for the topics which we do see now also with COVID, very fast ramp up of materials which are needed here. So how can we do this? How can we ensure high quality, and how can we ensure costs also, and efficiency, which efficiency is directly matched with sustainability? And this is, I would like to show on this part in Smart Factory, where it's important to understand the frame, what we define as a smart factory. We are not looking into the raw material supply or in the logistic part, but nevertheless, it's an important part that we have really production, pilot plant, lab, all these topics is part of this smart factory. So we have a whole life cycle of the materials coming from research development parts into our production, and then also the phase out of the materials. And as I explained before, it's urgent and it's very important for us. We do have to be faster in implementing or bringing in new materials into the market. Quality and sustainability is directly running together with efficiency. And efficiency, and we all know this, flow chemistry is really process intensification perfectly used. And with this, it is important, and it is a part of our initiative here. For sure, we want to reduce costs, but cost is also directly driven with high yields, low, let's say, materials used, raw materials used, or solvents used in the synthesis. And we do see examples all over the world how we can leverage flow chemistry to focus on this topic here. I think, and I'm a little bit sad that I missed this slide. As Volker mentioned, we started really in 2000 focusing on flow chemistry, and we already built different kind of modular plants, but modular plants and standardization only, let's say, focused on the hardware perspective and not on the automation perspective, because it was not possible. We do have this process intensification, so this is really, it's running, it's working, and we can also have advanced process control. But our focus is the future, and for sure, and you probably also see this as a very important part, digitalization. And at the end, it's the summary of this digital twin. So this is the important part we are working on. We do want to really use the data. We do want to bring in more simulation and more understanding of the processes, and this is important to really go forward into the future. So how can we do this? And I already mentioned this, enable connectivity. I do not know exactly how the community in Australia is already aware of this, this new topic called module type package, but I will explain it. You have to know that this was grown in the German community together with BASF, together with Evonik, so all the global players situated in Germany, and it's now on the rollout phase worldwide. So also in the US now, we do have collaborations here to forward this standardization of automation. What is behind this MTP? You really can compare it as a USB. It's just really the chemical world here. So what we have is we have, and I just use this slide deck here, you create modules. The definition of a module is broad. It can be a really big module. It can also be a very small part. Nevertheless, all these modules have an intelligence inside. And compared to the computer world, it is a driver. So the driver itself is telling the overall system what is capable to do with these kind of modules. And the only thing what you're doing, you use one LAN cable cable to connect to your process orchestration layer, and then you are able to use and to upload recipes, to steer your modules. So you can do everything you would like to do, and you can, with this, also are able to combine different kind of modules. And now coming to this benefit, and the benefit is really the new world. So what we can create now is we can create a platform or an infrastructure. And with this infrastructure also holds different kind of, or can hold different kind of modules. So then with this, you're starting to standardize your modules as you have known as, for example, from a multi-purpose plant. But these modules are much more flexible. And with this, you're able to introduce flow chemistry and highly efficient, let's say, technology into your overall system. So you're not anymore driven by, this is the multi-purpose plant, this is your batch vessel, and hey, you can do a lot of different kind of chemistry inside, but it's not really the efficient part. The efficiency now is coming with this system here, because with this, you're able to introduce different kind of technologies, perfect technologies matching to each kind of chemistry. And this enables you to bring it into your production. So this is really this break of paradox. Yeah, we have the flexibility on the one hand, but on the other hand, we can be really efficient. How does this look like? And this is the actual situation where we're working now. We have a new development building in Darmstadt where we are hosting and developing different kind of modules. We are processing or developing our processes on these systems. And if we are ready to say, okay, now they're ready to be in a production, we just really transfer the modules, the hardware, the software, the recipes, everything to our production site, and then we can start producing. And if we are finished, we can bring backwards the modules. And with this, we really have shared assets. And this is also an efficiency part, and it also directly goes into this topic of sustainability. The systems which we are building can be used everywhere and overall. And with this, we really also have we do not see, let's say, modules standing somewhere because they cannot be used anymore, or they are not used because the materials or the product which we will produce over there is not used on the market. So with this, they are able to use everywhere and for different kind of processes. Where's the benefit, and how are we using it? So what you see here is a small set of modules capable to produce about, or to handle a 2 to 3 synthesis step system. You can bring it in one walk-in hood. And the really cool thing is we are talking about production amounts about 3 tons per year using just these small systems here. And this is very important because we do see really a decrease of demand, but an increase on quality and sustainability efforts. So with this, systems which are easily capable to do this. And I just really put it in some numbers here. So this system here can be fully automated within 1 day. So you connect everything and then you can start programming your recipes. If you're used to the chemistry which you want to do here, it's typically taking you to, let's say, 2 to 3 days to optimize your system, and then you have a running recipe which you can directly use also in production. So you would then transfer these systems into our production capabilities here, upload the recipe, and then you could start doing the production. And flow chemistry is for sure one of the biggest advantages here, because you can implement different kind of chemistry, you can implement different kind of technology, and on the other hand, it's small systems which are capable to produce big amounts. You can also think about dedicated systems here, and this is really a great advantage. Our biggest project actually in Darmstadt, and I'm the project lead for this system, for this project, is now we are building this production plant, and it's a funded project in Germany. This is why we have this German name. But nevertheless, the main focus is really that we have to reorganize our workflows, because this is tremendously changing our world of production and development. We are installing this process orchestration and this automation technology together with Siemens. So because this is the first production plant, which is then able also to have this process orchestration layer from Siemens. And this is a German topic. we are working on the authority approval, because in Germany you need authority approval for doing production, and with this is also a very important part and an important step in Germany, that we are able to have this flexible production capabilities and that they are approved by our local authorities here. So what is coming next? And data is the new oil, and I think this is for all of us. It's clear. I mean, I just really stated this article here, and this was from 2017. Everyone knows this. Data is important for us in the future. And what kind of data are we talking about? And I just really show that the usage of data already is growing. So basic statistics, multivariate analytics, advanced analytics. So these are parts which we already do. For us, and this is the next thing, what is coming up is really the use of artificial intelligence. And how are we using this? And then it's going along with engineering knowledge. Yeah, the combination, I just really clicked through these parts, is it's a cycle. So what we're doing, we can collect data. The data is part of online monitoring, and the online monitoring helps us also with real-time predictions to have, let's say, the operators assistance systems programmed. And here we also use this, let's say, neutral network systems. We really start to help the operator understand the process, and not only by his knowledge, it's the data which helps to understand him. So with this, if he do see, let's say, that there is something happening in his process control system, he will get directly a feedback from the system explaining it should be better if you decrease temperature because of. And I think this is a very great advantage, and this is only capable and doable if you have these systems, the data available and the automation available in your modular plants. So how does this look like for the future network? I already said this, automation is part, and the key part is this fair data. So findable, accessible, interoperable, and repeatable data. So this is this fair data system, and this is directly possible with this kind of automation. What are we doing on the AI part? And we fill the gaps, I would say. So there's a lot of things which we do not exactly know nowadays. So for example, the physical properties of materials, there's only a small percentage available. So with this, we really start to use AI to fill this knowledge. So with this, we can also start to module design much better. We can do process digitalization here. So there's a lot of things you can really start to use AI in your process development. And all these, the modularization, the flow chemistry, the AI, all these things is coming at the end and supporting the life cycle of the materials. So we can shorten our R&D time, we can shorten and ramp up and do the ramp up much better in a much better robust way, and we can directly support our production. And I think this is the initial part where we really see now where all these topics where we worked a lot of years on are coming together and helping us to be much more better in the future. And so with this, my last slide, smart module support, fair data, sustainable processes, and reliable supply chain. I think these are the key messages which I do really see, and this is why we're working on these topics. And sorry that I didn't present a lot of chemistry, but nevertheless, I hope that I explained why flow chemistry was one essential part in our, let's say, future production environment. And with this, the journey has begun, but still be curious, and we are on the way. Questions?
Yeah, thank you so much. That was a great, Sebastian. You know, AI is ultimately important in Australia, and people are really good here. So it's good to hear that that went now into the business. So please put questions online. I have an eye on it. Give me a question, I will give it immediately to you. I don't see now a question. I have naturally a question, but maybe one of the panelists might go with a question, but the attendees should write some question, takes a chance. So who of the panelists might want to give a question? I start then maybe. very interesting to see you put up the whole way from the gram scale to the ton scale. And I think you did not quote on, especially for flow chemistry, how do you scale up? I mean, you have the modules, you can flexibly assemble them, but the gram module, say for a flow reactor, and the ton module for a flow reactor, is that just numbered up, or how can we imagine that?
No, then it's for this system here, it's just really a small system, and it's capable to, as it runs continuously, it's capable to produce 3 tons per year. So this is not a matter of topic. For sure, and this is the explanation also which we discussed with our colleagues in process, or let's say in product development. If we need to scale up more, then it's the one thing that we can think about scaling up, or also really numbering up. And this is the possibility is there. It's just really a matter of what fits to the product and to the needs of the market.
Okay. Any question? Let me know.
Christian.
I look. Yeah, who is that?
Christian.
Christian Holze, perfect. One speaker asks the other. Good. Yeah, give your question.
Hi, Sebastian. Very nice talk. Can you comment on whether you think that flow chemistry has reached the technology readiness level to be deployed in industry as a proprietary technology, or do you think there is still a lot of room for pre-competitive collaboration in publicly funded formats?
I would say from the only just focusing on the flow chemistry, I would say that we do see a lot of examples which directly help us to explain it's worth to go forward it, and we can directly, I would say, no, let's come from the other world. Technology readiness level for flow chemistry, I would say we are in production. So we are at the point that we can directly utilize it and use it. The interesting thing is now, we do see that we have to understand where can we use it in the chemistry part way. So we do see there a development on, for example, a chemist is mainly focusing on screening different kind of catalysts, screening different kind of ligands, only just working on, okay, this is the perfect, let's say, set from the chemistry part to do a Suzuki reaction. Yeah, I'm coming from the next step and saying, okay, this is only one dimension, the chemistry. The next dimension is how can we use technology? And if this is the combination where it's getting interesting. So if we're talking about sustainability, not only ask what is the best way doing it from a chemistry part, but in addition, can you design also the chemistry in comparison that we have a very nice downstreaming unit, for example, in the next step. And with this, you could switch to a total other solvent, because then it's much easier to be separated in our downstream part. So we do have to think a little bit more in a total way, not only on the chemistry part. And the modularization and flow chemistry directly helps to do this. Yeah.
Good. We luckily have now a question from the audience, from the attendees. The question is, are there already commercial suppliers offering dedicated modules to address specific tasks or reaction classes? So do we have specific commercial modules for tasks and reaction classes?
I would say no and yes. The one thing is, for example, seeing that we can do also flow chemistry in extruders, or for example, also what the CSIRO is working on, catalysts directly on different kind of reactors. The technology with flow chemistry is there, and we do have different kind of suppliers for these technologies. I mean, at the end, all the suppliers for a flow reactor are there. The only thing is now we have to build in them in different kind of modules and do the automation. And this is the new world which we are now stepping in. Evonik is also really heavily working on this. And this is mainly actually now built in-house, because we have to build up this knowledge of how to do this. But nevertheless, it's coming. For example, Uber as a supplier for cryostats, they already have a cryostat where you can directly purchase with an MTP inside. And this is this evolving part now, which is coming. And the combination is a great thing from my point of view.
Okay, thank you. I don't see another question in the chat. We would still have 4 minutes, but since I suppose we will have more questions when we get warm with the talks, I would say, no, there's one question. That is the last one from Tash Folios, which I accept here. Is inline purification necessary to post-production? That's the question. So that's the last one.
Yes. And this is this topic of how can you combine chemistry and purification in one system, and the modularization enables you. And this is what I would like to explain also to the question before. We do not have to think about nowadays only on chemistry. The interesting thing is really the combination of the whole process. What kind of downstream units do you have, and what is the best combination? So is it a little bit better to not focus on the best yield in the chemistry, decrease your yield, but with this you're able to use a solvent which you directly can easily separate in your downstreaming units, for example, or a green solvent, yeah. And the combination is the new world, and I think this is the important part in the future.
Okay, I think we had a great talk and a good first discussion. Thank you, Sebastian, for joining us, and thanks to Merck Company.